Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video. In this video we are going to solve several problems relating to differentiation. Okay. This is a set of problems which consists of problem number 7 to 52 from the book Calculus Early Transcendentals by James Stewart, Slim Watson and Daniel Clegg. Okay. Total set of problems consist of problem number 7 to 52. But in this video we are going to solve only problems up to 20. That is from problem number 7 to problem number 20. Okay, find the derivative of the function. Okay, it is not necessary to state all these problems in the beginning of the video. Okay, as soon as we will come to solve these problems, we will state each problem. Okay, problem number 7 to problem number 20. Okay, now as usual, before starting our solution in a formal manner, we first visit several snapshots which will provide a basis regarding understanding of the concepts involved in these problems. Okay, dear students, these problems mostly relate to chain rule. Okay, so first slide or copy paste version is about the chain rule. The chain rule: if g is differentiable at x and f is differentiable at gx, then the composite function f equal to f composed with g defined by f x equal to f into gx. F composition of gx is differentiable at x and f dash, that is derivative of f, is given by the product f dash x is equal to f dash gx dot g dot dash x. Okay, first f dash gx and then the function inside the f dash, that is g dash x, derivative of gx. Okay, in Leibniz notation, if y is equal to fu and u is equal to gx are both differentiable functions, then dy by dx is equal to dy by du dot du by dx. Dear students, this is power rule combined with chain rule. Okay, previously we have dealt with power rule, but here power rule together with chain rule is being introduced. Okay, the power rule combined with the chain rule: if n is any real number and u is equal to gx is differentiable, then d over dx u raised to power n is equal to n into u raised to power n minus 1 du over dx. Alternatively, d over dx gx raised to power n is equal to n gx raised to power n minus 1 dot g dash x, that is derivative of gx. Now another version of the chain rule, okay, chosen from some other book. The chain rule: if u equal to fu is, if y is equal to fu is a differentiable function of u and u is equal to gx is a differentiable function of x, then y is equal to f of gx is a differentiable function of x and dy by dx is equal to dy by du dot du by dx. Or equivalently, d over dx f of gx is equal to f dash gx into g dash x. Okay, that is first derivative of f of gx and then derivative of gx. Another version, chain rule. Okay, if f and g are differentiable, then the composite function f composition g of x is equal to f of gx is differentiable, and f of gx whole dash is equal to f of dash gx into g dash x. Okay, another version, chain rule. Chain rule, if fu is differentiable at the point u equal to gx and gx is differentiable at x, then the composite function f composition gx is equal to f of gx is differentiable at x, and f composition g dash x is equal to f of dash gx dot g dash x. Okay, that is first differentiation of f of gx, then differentiation of gx. Okay, in Leibniz notation, if y is equal to fu and u is equal to gx, then dy by dx is equal to dy by du dot du by dx, where dy by du is evaluated at u equal to gx. Another version, chain rule, if g is differentiable at x and f is differentiable at gx, then the composition f composition g is differentiable at x. Moreover, if y is equal to f of gx and u is equal to gx, then y equal to fu and dy by dx is equal to dy by du dot du by dx. Dear students, in one or two of problems involved in this video, this property of logarithm will also be used. Okay, converting to base e expressions, 3 raised to power x is equivalent to e raised to power x into log 3. X raised to power 3 is equivalent to e raised to power 3 log x. Similarly, 4 dot 2 raised to power x is equivalent to 4 dot e raised to power x log 2. Okay, dear students, these three formulas are related to conversion of base e expressions. Okay, 3 raised to power. Okay, because in one of our problems we will deal with 5 raised to power x under root. Okay, in our problems we will meet a situation in which we will have to solve 5 raised to power x under root. So we will use this formula, that is 5 raised to power x under root will be equal to e raised to power x under root into log 5. Okay, using this property we will solve that problem. Okay, now derivative of the natural logarithmic function, let u be a differentiable function of x, then formula number 1, d over dx log x is equal to 1 over x. Okay, differentiation of log x is 1 over x, and formula number 2, d over dx log u is equal to 1 over u into du over dx, because we are differentiating with respect to x, while log is in terms of u. That is why this second formula will be used in that case. Dear students, in formula number 1, situation is quite clear, straightforward, that we are differentiating with respect to x and log is also in terms of x. So its differentiation, its derivative will be 1 over x. But in formula number 2, we are differentiating with respect to x, while log is a function of u. That is why d over dx log u will be equal to 1 over u du over dx. Now dear students, we are going to start our solution in a formal manner. Okay, problem number 7, fx is equal to this. Okay, this implies that f of dash x, because f is a function of x, so f dash x will be d over dx into the same function. In the next step, using chain rule, first we will apply power rule, that is n x raised to power n minus 1 into derivative of the internal function. Okay, so here it will become 5, then power 1 minus 1, that is 4, power 4, 5, 2x cube minus 5x square plus 4 raised to power 4, because here d over dx x raised to power n is equal to n x raised to power n minus 1, power rule. So here 5 will be reduced by 1, and then we will take d over dx of the internal function. In the next step, then d over dx will distribute over 3 adding factors. Okay, that is to say, moreover, a constant, that is, in the first term 2 is constant, in the second term 5 is constant, and the third term is completely constant. So in first 2 terms, constants will be taken out of d over dx, but with the third term the situation is quite different, because third term is entirely constant, it is not being multiplied with x or x square or x cube. Okay, so dear students, we have taken constants of first 2 terms out of d over dx. Now differentiation will apply only to x cube and x square. So in the next step we will get differentiation of x cube will become 3x square, and it is being multiplied with 2, so it will become 6x square. Similarly, differentiation of x square will become 2x, and it is being multiplied with 5, so it will become 10x, while differentiation of 4 will be 0, because 4 is a totally constant factor. Okay, it is not being multiplied with any x or x square or x cube, etc. Okay, so then just simplification remains. Okay, so after simplification our answer becomes 10x into 10x into 2x raised to power 3 minus 5x square plus 4 raised to power 4 dot 3 into dot means dot stands for multiplication, but it is not necessary. If we do not write this dot, even then our answer will be quite correct. Here dot is not necessary, it is just as a matter of discretion being used. Okay, dot is not necessary. 3x minus 5. Okay, now we come towards the problem number 8. fx is equal to this. Here, because power is 50, so f dash x will be d over dx into this whole function, because the fx is a function of x. Okay, now once again, according to chain rule, this d over dx x raised to power n equal to n x raised to power n minus 1. Okay, so 50 into x raised to power 5 plus 3x square minus x will raise to power not to 50 but to 49. That is to say 50 minus 1. Then d d over dx internal function x raised to power 5 plus 3x square minus x. Okay, in the next step, dear students, d over dx will distribute over the three adding terms. Okay, and then moreover, here in the central term 3 is a constant, so this 3 should be written prior to d over dx, because differentiation will apply only to x square, while 3 is a constant. But here constant will not approach to 0 because it is being multiplied with x square. Okay, so differentiation of x square will become 2x, and this 2x is being multiplied with 3, so it will become 6x. Moreover, differentiation of simply x with respect to x will be 1, that is unity, and differentiation of x raised to power 5 with respect to x will be 5x raised to power 4. Okay, hence after simplification our answer becomes 50 into x raised to power 5 plus 3x square minus x raised to power 49 into 5x square plus 6x minus 1. Now we come toward problem number 9. Fx is equal to this. Here, dear students, square root or under root sign is equal to power 1 by 2. Okay, so alternatively we can write it as 5x plus 1 raised to power 1 by 2 here, because we are going to apply chain rule combined with power rule. Okay, so f dash x equal to d over dx, this here it will become 1 by 2 into 5x plus 1, 1 by 2 minus 1. When 1 is subtracted from half, then it will become minus half. So half 5x plus 1 minus half raised to power minus half into d over dx 5x plus 1. Dear students, here in the next step we will distribute d over dx over the two adding terms. Moreover, 5 is a constant, so 5 should be written prior to d over dx, because differentiation is going to apply only to x. Moreover, second term, which is 1, which is a pure constant, it will give 0 result, because it is not being multiplied with any x or x square or x cube. Okay, so its differentiation will become 5 into 1 plus 0. Okay, so we will get 5 over 2, 5x plus 1 raised to power minus 1 by 2. This will become equal to, this will become 5 over 2, 5x plus 1 raised to power 1 by 2, because power minus 1 by 2 in the denominator, in the numerator when shifted to denominator will become plus, and this will become equal to 5 over 2 into 5x plus 1 under root or square root. Okay, yes. Now we are going to solve problem number 10. Fx is equal to 1 over x square minus 1 raised to power 3 over square root sign. Okay, this is equal to 1 power 1 by 3. This is called cube root. Okay, if we when we say simply cube, it means power 3. When we say cube root, it means power 1 by 3. So it will be equivalent to 1 over x square minus 1 raised to power 1 by 3, and this will be equal to power minus 1 by 3, because here denominator is being shifted to numerator, so power plus 1 by 3 is going to be changed to minus 1 by 3. Okay. Now f dash x will be equal to d over dx. This now we are going to apply chain rule together with the power rule. Okay, so it will become minus 1 by 3 x square minus 1, its power minus 1 by 3, from this power 1 will be subtracted, and then derivative of x square minus 1 will be taken. Okay, yes students, differentiation of x square will be 2x, while differentiation of 1 with respect to x will be 0. So after simplification our result will become minus 2x over 3 x square minus 1 raised to power plus 4 by 3. Okay, because power minus 4 by 3 in the numerator when shifted to denominator will become plus. Okay, power minus 4 by 3 in the numerator when shifted to denominator will become plus 4 by 3. Problem number 11, gt equal to this will be equal to power minus, because power 2 is in the denominator, when shifted to numerator it will become minus 1. Now we are going to apply, now we are going to differentiate it with respect to t, because g is a function of t. So applying chain rule together with the power rule, okay, it will become minus 2 into 2t plus 1 minus 2 minus 1, that is minus 3 into d over dt 2t plus 1. Here differentiation of 2t with respect to t will become 2, while differentiation of 1 with respect to t will be 0. Okay, because 1 is a purely constant factor, it is not being multiplied with t or t square or t cube etc. Okay, so this 1 will give 0 result, while 2t will give 2 result, because the differentiation of t with respect to t will be 1, so we will get 2 into 1. Okay, hence after simplification of our answer becomes minus 4 over 2t plus 1 power raised to power 3. Okay, because power minus 3 in the numerator when shifted to denominator will become plus 3 instead of minus 3. Okay, problem number 12, ft is equal to this power 4. So this power 4 will be of 1 as well as of 2t plus 1. Power of 1, fourth power of 1 gives once again 1 result. Even whatever is the power of 1 except power 0 will give 1 result. However, even power 0 will also give 1 result. Okay, anyhow, it means 1 raised to power 4 over 2t plus 1 raised to power 4. Here, because power 4 is in the denominator, plus when shifted to numerator it will become minus 4, 2t plus 1 minus 4. So then f dash t is equal to d over dt into the whole function, because f is a function of t. Now we are going to apply chain rule together with the power rule. Okay, so it will become minus 4 into 2t plus 1 minus 4 minus 1, that is minus 5, and then d over dt 2t plus 1. Yes students, here differentiation of 2t with respect to t will give 2 result, while differentiation of 1 with respect to t will give 0 result, because 1 is a pure constant factor, it is not being multiplied with any t or t square or t cube etc. Okay, so quite simple. Next, just simplification. Okay, so after several simplification steps our answer becomes minus 8 over 2t plus 1 raised to power 5. Okay, because in the previous steps 2t plus 1 is raising to power minus 5 in the numerator, and when shifted to denominator this minus 5 power becomes plus 5. Okay, now problem number 13. Here f is a function of theta, f theta is equal to cos theta square. So f dash theta equal to d over d theta into cos theta square. Because f is a function of theta, so f dash theta will be equal to d over d theta into cos theta square. We know that differentiation of cos theta is minus sin theta. Okay, so we will get minus sin into theta square and then d over d theta of theta square. Differentiation of theta square with respect to theta will become 2 theta. Okay, and hence our answer will become minus 2 theta sin theta square. Now problem number 4. G theta is equal to cos square theta, G dash theta equal to d over d theta into cos square theta. Here G is a function of theta, so G dash will be d over d theta cos square theta. So okay, now we are going to apply chain rule together with the power rule. So it will become 2 cos theta and then differentiation of cos theta, that is d over d theta cos theta. We know that differentiation of cos theta is minus sin theta, so we will get 2 cos theta into minus sin theta, and it will become equal to minus 2 cos theta sin theta, and it is equal to minus sin 2 theta because here within the bracket it is written that because these 3 dots denote because or since, giving argument that this is a trigonometric identity or trigonometric formula that sin 2 theta is equal to 2 sin theta cos theta. So using this formula our answer has become equal to minus sin 2 theta. Problem number 15. Gx equal to e exponential function. Okay, g dash x is equal to d over x into same because g is a function of x. Okay, now in the next step we are going to apply power rule, chain rule together with power rule. We know that derivative of exponential function first remains as it is, then we will differentiate power of exponential function. Okay, so d over dx e raised to power x square minus 1, first time it will become as it is, e raised to power x square minus 1, then we will differentiate x square minus 1, that is d over dx x square minus x. Dear students, the differentiation of x square with respect to x will give a result 2x, and differentiation of simply x with respect to x will give result unity 1, that is we will get 2x minus 1. So our answer becomes g dash x becomes equal to e raised to power x square minus x into 2x minus 1. Okay, here dot denotes multiplication. Dot is not necessity. Okay, it is a matter of discretion. Even if we do not write this dot, it is quite correct answer. Okay, dot is a matter of discretion. Dot is not necessary. Okay. Problem number 16. Y equal to 5 raised to power x square root or x under root. Dear students, in our snapshots we have shown a snapshot in which logarithmic identities were given. Okay, so using that property, y equal to 5 raised to power x under root becomes equal to e raised to power x under root into log 5. Okay, according to that property which we have shown in our previous snapshot. Okay, this implies that dy by dx equal to d over dx into the same. Then we know that differentiation of exponential function, you applying chain rule together with the power rule, exponential function is first written as it is, and then we just differentiate power of e. Okay, so it will become e raised to power x under root or square root into log 5. Then we will differentiate x square root or x under root into log 5. Okay. Then in the next step we have once again written e raised to power x under root or square root log 5 equal to 5 raised to power x square root or x under root. Okay, because this conversion was actually needed to be applied first time in order to reshape our statement, and then in the later stage we can once again substitute its alternate value where necessary. Okay, so we will get dy by dx equal to 5 raised to power x into d over dx x square root or x under root into log 5. This will become equal to 5 raised to power x square root or under root into, okay dear students, this is a product rule. Okay, x square root or x under root is 1 and log 5 is other. Okay, so first we write x square or x under root as it is, and we take differentiation of log 5 with respect to x. It will give 0 result because in log 5 there is no x. Okay, its differentiation will give a 0 result, plus log 5 into d over dx x square root or x under root. Here it will, here power rule will apply, and x square root or x under root is equal to x raised to power 1 by 2. So 1 by 2 will become as a multiplying factor, and power will be reduced by 1. That is 1 by 2 minus 1 equal to minus 1 by 2. And power minus 1 by 2 when shifted to denominator it will become plus 1 by 2. Okay, so applying this methodology, our answer becomes 5 raised to power x square root or x under root into log 5 over 2 into x square root or x under root. Okay, any confusion? No confusion. Main thing is that we have used logarithmic identity. Okay, problem number 17, y equal to x square into e raised to the power minus 3. Okay, here function is a product of two functions. Okay, product rule will apply. Okay, so dy by dx equal to d over dx into this. Okay, now its differentiation will take into its differentiation will be taken in such a way that one time we will take a first function and then differentiate second function, and plus vice versa. That is, we will differentiate first function and keep second function as it is. Okay, so x square into d over dx e raised to the power minus 3x plus e raised to the power minus 3x into d over dx x square. Okay, dear students, differentiation of x square with respect to x will be 2x, while differentiation of e raised to the power minus 3x will be one time it will be written as it is, and then it will be, we will take a derivative of minus 3x which will give result minus 3. Okay, so using these properties, our next step becomes x square into e raised to the power minus 3x into d over dx minus 3x plus e raised to the power minus 3x into 2x. What is 2x? 2x is a differentiation of x square with respect to x. So in the next step we get x squared into e raised to the power minus 3x into minus 3 plus 2x e raised to the power minus 3. This becomes equal to x e raised to the power minus 3x into minus 3x plus 2, and finally after simplification our result becomes, after our answer becomes x e raised to the power minus 3x into 2 minus 3x. Problem number 18, f is a function of t, ft is equal to t sine pi t. Okay, then f dash t equal to d over dt, because f is a function of t, so it will become this. Now dear students, this function is a product of t and sine pi t. Here product rule will be applied. One time we will write t as it is, and we will differentiate sine pi by t, sine pi t, plus then we will keep sine pi t as a constant as it is, and we will differentiate only t with respect to t. Okay, so we got t d over dt sine pi t plus sine pi t d over dt 1 d over dt t. Dear students, differentiation of t with respect to t will give a unity result 1, while differentiation of sine pi t with respect to t will give cos pi t, and then differentiation of pi t, that is pi. Okay, so using these properties, our next step will become t into cos pi t, then d over dt pi t plus sine pi t into 1, because the differentiation of t with respect to t will give a unity result, one result. Okay, so next step will become t into cos pi t into pi plus sine pi t, and this will alternatively become equal to pi t cos pi t plus sine pi t. Problem number 19, ft is equal to EAT sine BT. This implies that f dash t equal to d over dt into same function, because f is a function of t. Now dear students, this function is a product of two functions, that is e raised to power at is 1 and sine bt is other. Okay, here product rule is going to be applied. So in the first step we will keep e raised to power at as it is, and we will differentiate sine bt, plus we will keep sine bt as it is, and we will differentiate e raised to power at. Okay, dear students, differentiation of sine bt will become cos bt, and then differentiation of bt which will give result simply b, while differentiation of e a raised to power at will be first as it is, that is e raised to power at, and then differentiation of at, that is which will give result simply a. Okay, so using these rules or properties, our next step will become e raised to power at into b, whether we say into or we say dot or we do not use dot, it is a matter of discretion. Okay, e raised to power at into b into cos bt plus sine bt into e raised to power at into derivative of at with respect to t, it will give us result a. Okay, so our next step will become e raised to power at into b into cos bt plus sine bt into e raised to power at into a, because differentiation of at with respect to t will give result a. So our answer finally becomes e raised to power at into b cos bt plus a sine bt. Problem number 20, a is a function of r, r is equal to r square root or r under root into e raised to the power r square plus 1. Here function it is a product case, r square root or r under root is 1 and e raised to the power r square plus 1 is other. Okay, so product rule is going to be applied. So a dash r is equal to d over dr, because a is a function of r, so whole function. Then one time we will keep first function as a constant and differentiate second function with respect to r, and then plus we will keep second function as it is and differentiate first function with respect to r. Okay, so dear students, here differentiation of e r square plus 1 with respect to r will be if one time it will be written as it is, that is to say e raised to power r square plus 1. Then we will differentiate power of e, that is r square plus 1. It will give a result 2r. Similarly, in the plus second factor, d over differentiation of r under root, that is r raised to the power 1 by 2 with respect to r, will become 1 by 2, which is power will be written as a multiplying factor, and 1 will be subtracted from power. Okay, so when 1 is subtracted from half, it will become minus half. Okay, so we will get r square root or r under root into e raised to the power r square plus 1 d over dr r square plus 1 plus e r square plus 1 over 2r under root. Okay, because I have said that when 1 is subtracted from half, power remains minus half, and minus half when shifted from numerator to denominator, it becomes plus in the denominator. Okay, so the next step we will get r square root or under root into e r square plus 1 into 2r. 2r is a derivative of r square plus 1 plus e r square plus 1 over 2r under root. This becomes equal to 2 into r raised to the power 3 by 2 into e r square plus 2 plus e raised to the power r square plus 1 over 2 into r under root. Dear students, here we take 2 into r square as common, and then 2 into r under root or r square will be multiplied with 2 r raised to the power 3 by 2. So 3 by 2 plus 1 by 2 will be equal to 4 by 2, and 4 by 2 means 2. So dear students, after simplification, our answer becomes e raised to the power r square plus 1 into 4r square plus 1 over 2 into r square root or r under root. Okay, this is the end of our video. This is the end of our problems. Till next video, till next problems, Allah Hafiz.